Welcome to another unit in the workbook Statistics. This time I'm going to talk about the F-test. Well, if I say F-test, I'm particularly talking about the F-test which is relevant in the context of linear regression. There might be different applications for the F-test. Here it's focused mostly of using it in the context of a regression analysis. Well, what's the general idea which the F-test tests? For this makes sense to take a look at the H0 and H1 hypothesis. So we usually say that the F-test tests whether there is a relation between the dependent variable y and the independent variables x, y. However, the idea is we are doing this to show whether the model has no or significant explanatory power. That's, however, not really what is tested. What is tested is more or less whether one of the coefficients is significantly different from 0. Well, at least one of the coefficients, or H0, all coefficients are equal to 0. Well, how do we go about this? We first calculate the test statistic, which for the F-test looks like this. I said it's focused around linear regression. That's why here we already have our R squared, the coefficient of determination. We're going to divide this by the number of x variables, so by the number of independent variables. Now we divide this result by 1 minus R squared divided by n minus k minus 1. So number of observations minus number of independent variables minus 1. The minus 1 comes from the intercept of the linear regression. So that's actually how many coefficients we have to estimate. Well, once we have this test statistic, we need to compare this with a reference statistic, which for the F-test looks as follows. We have the k, that's the same k as here, that's the number of independent variables, n minus k minus 1, which we also call the degrees of freedom. That's again number of observations minus how many coefficients we need to estimate. And then we have 1 minus alpha. The F-test, if we actually look up this reference statistic in a table, is a bit different than, for example, when working with the t-statistic or the chi-squared statistic, because we have 2 times different degrees of freedoms. So a table can only cover so much. We have 3 values here. Tables are 2-dimensional. So usually there is one particular table for the 1 minus alpha. So if we have an alpha of 5%, you take the table for 0.95. If you have an alpha of 1%, you take the table for 0.99. Then you get something like this. And here, usually the columns, that's the first one, that's why it's here called N1. The columns is the first value mentioned here. In this case, the different independent variables. Whereas the rows, that's the second one, that's the number of observations minus k minus 1. But this usually also makes sense because here the values in most cases are limited up to 10. But there's very few columns. If you go down, well, I cut this off at this point, but it usually continues to some thousands downwards, because you might have much more observations, and in this regard much more degrees of freedom in the middle one than you have independent variables or degrees of freedom in the first one. Well, if you look up this value, you take a look at the first one, the k. The k tells us what's the respective column we're using here. Then you take a look at the n minus k minus 1. That tells you which row you're using. And then you look up the respective value. Well, that's basically everything there is regarding the F-test. Test statistic, reference statistic, and as with most tests, if the test statistic is larger than the reference statistic, we're going to reject H0. We assume H1 to hold true, or in other words, if the test statistic is larger than the reference one with the f-test, we could say that our regression model has significant explanatory power. So it's a model which we can decently well use. Well, that's then already everything I wanted to mention regarding the f-test and how to conduct this. Hope you enjoyed this session. I say goodbye and see you next time.